Pandas, which stands for panel datasets. Usually we use Pandas libraries whenever we want to deal with tables or CSV sheets. So in my case, what I will be showing you is all the data types that are in Pandas, and then how do we access a simple Excel sheet or a Google sheet or a simple table. How do we apply operations on top of that table? How do we apply mathematic terms on top of those tables? So this is how usually data analysis people also do it. So let me take an example URL for you guys to access it. A little bit of introduction about this Pandas will be here for your understanding. So Pandas stands for panel data, and it is a core library for data manipulation and data analysis, and it consists of single and multidimensional data structure and manipulations. So from Pandas, whatever it's necessary for our basic electricals are that we need to understand the data types involved in it. First thing is it consists of a data type called series, and it also consists of data frames. These are the data types, data structures involved within the library Pandas. It means you can define values in these two ways. So a collection of series becomes a data frame, and a series is nothing but a simple NumPy array in the previous library. The Pandas library is technically using and built on top of the basic library NumPy itself, guys. It's no different, but we will take few concepts of NumPy arrays even in Pandas. This is exactly why we started NumPy first. So let us take an example of series. So if you want a theory about it, I'm directly giving you the content here. A series is nothing but a one-dimensional labeled data structure which can hold all the items. So we can give it a read for it. All right, so now that we are into Pandas, how do we use Pandas related libraries and how do we use Pandas related functions? So as we imported the NumPy initially with import keyword, here also we are going to use import Pandas as is an alias name. You can give any letter you wish, anything you wish, but whenever you want to access Pandas, you can just do PD. This is how you import Pandas. And if I have to create a series, it means that it's nothing but a row, it's nothing but an array. So let me just give you a brief about it. What all we learned since our day one is we do understand that there is a list which is in this format. We do understand that now that we understood an array, which is a NumPy library data type, data structure, and now we are going to Pandas. So Pandas technically consists of series and also data frame. So what are these things is a series again technically uses an array itself. So Pandas library is used to deal with tables with multiple rows and multiple records. So one row is nothing but one series for us. It's nothing but an array. So one column is nothing but a column or a record for us, which is nothing but features in terms of data analysis. But one column is a feature. In this case, one series is nothing but one row value. So all the values in these can be defined in an array like this. So right now we are trying to define what is an array in under Pandas library and what is a data frame. So we'll check that with a code snippet. Let me now try to create a simple series for you. A equals to PD. A is equals to is just like I am storing my series in some variable. PD is the name that I gave. Series, please be very careful with the case sensitivity. Series consists of capital S, not the small s. Because it's a method, you have to strictly follow the rule of it. Series of 1, 2, 3, 4. So it is nothing but basically I said it's a list or it's an array. So series is nothing but an n dimensional array, in this case a single dimensional array. So if you give an input like this, let us see how does it look like. You do see that it immediately frames a table kind of structure for us, which is obviously not in a good visualization. We don't have any boxes here, but a series, when you give it like this, it is generating just like a table. Zeroth row is 1, first row is having 2, second row is having 3, fourth row, third row is having 4. If you are confused with these numbers, let me give alphabets for it. You do see that these are the values that I gave, and this is the indexing that it is following, just like an attendance register. So in this case, you don't want 0, 1, 2, 3 like this. You want something else customized. That is also possible. You can just take another parameter inside the function called series by mentioning it as index. Again, how do we remember all this? It's just a practice, guys. Index is the most famous parameter that we use. So you can say, I would like to have indexes like, let's say 5, 6, 7, 8. Why am I writing 4 numbers? Because there are only 4 values. So let me run this and check. So this is how it prints. You can have customized positions and customized values like this. This is how you build a series. You can also build alternative way of building a series is with dictionary in Python. If you see here, this is a list data type. Rather than this, I can give a dictionary like this. You do remember that dictionary is nothing but a key value pair. So you can say, I don't need this index parameter as well here. I will just say, in this case, 5 needs to have A, 6 needs to have B, D needs to have C, sorry, 7 or 8, whatever. So if I try to run this, this also create a series, just another alternative, nothing change. So you can either create with an input list like this, with a customized index like this, or with a dictionary format like this. So whatever value you give under keys, it will become your indexing. Whatever values that you give under values, it will become your values for the object. So again, this object is nothing but a data type. Basically everything is an object when it comes to internal data structure, so I don't think you need to worry about this object right now. All right, so that is how we do create a series. How do I create a random integer series? Is you can apply that random module which is there in the numpy on top of the series. For example, I would like to have my data created randomly dot rand. If you want only integers, you can give int. Let's say I want 10 rows and 3 columns. Give me another parenthesis. Random numbers. Let me correct it. Rand int Python. You see that start and stop plus 1. So in the W3 schools, so returns a number between 3 and 9, both included. So it randomly just gives a value between 3 and 9. So in my case, what I'm trying to generate is, let's say I would like to generate like this. So what I'm trying to do is it randomly generates a number between 1 to 10, which are 3 elements. So if you want 6 elements, you can give 6 elements. So in this case, it is randomly trying to generate 1, comma 2. Let's check the syntax again. 0, 4, 1, both included. What I'm trying to generate is a matrix altogether. So let's try changing syntax. This is just a number between this, and if is let us see if we can generate matrix. Fine. So what is it generating right now is any random number between 1 to 10, which are five elements. So the mistake that we were doing was just giving another parenthesis in it. In this case, let's say I would generate 15 numbers. This is what we were expecting earlier on. So if I am expecting 20 to 20 to 30 is a range. Let's say we can tell, can you please give me five numbers between the range of 20 to 30? So five numbers between 20 to 30. So what is the usage of this is right now I just created an array, but I want to convert this into a series. So our concept is about Pandas series. I would like to use this array as an input to my series. So what we will do is, as of now, I created an array by using random module from NumPy array concepts. So we will now create a series by giving data as an input to the series. You do remember that when we were initializing earlier on, so this is nothing but a list, or it can be an array, right? So we gave an input to the series and we generated series like this simultaneously. Similarly, I'm just giving a simple randomly generated array as an input to my series. So let us see what does it create for us. It will just generate a series based on the inputs that we have, right? So this is how you can generate a random number series on top of Panda series. And if you ask me arithmetic calculations, let us try doing arithmetic calculations on top of this. Let me try to store this in a variable called f. This is my series right now. Let me try doing arithmetic calculations like this. So what it is going to do is it will generate another series by adding the element wise itself. So 25 plus 25 is 50, 28 plus 28 is 56, 28 plus 25 is 50, and so on. So you can apply any arithmetic operations on top of this. Can be subtraction, multiplication, division, exponent, square root, everything it will apply on element wise, guys. So I think this is something we already discussed in our NumPy array. So I don't think we can spend time more on top of that. Let's see what else we can do with series. So if you see this code snippet, what am I trying to do is to randomly generate 15 numbers ranging from 1 to 15, and I'm converting that to a series called data1. Data1 is the value that I had, and I'm giving a name to that table called scores. So if I go for data1, it will generate a list, a series like this. By default, obviously it starts from 0 to 14. If you want customized things, just go back to my concept and use this parameter. You can have customized indexing. Right now I'm not worried about my indexing, so I just left it empty. So it generated with the values that it generated from data1 array, and I gave that as an input to series function with a name called scores. So the name that I'm giving for this entire series is scores. If you want to rename it, you can just say rename, and then you can give your own customized names on top of this. So in my case, let's say I would like to rename it to dummy. It will rename our entire table to dummy. All right. So now let's move on to our data frame. What is a data frame? So in this case, if you see here, one row is one series. It's nothing but an array is what we just discussed. It is much more similar to our NumPy arrays concept. But now we will discuss about multiple rows and multiple columns, which is nothing but a data frame. So if you see an example or for a data frame, let me give you theoretical understanding of it. So a data frame is a collection of series like this. So a data frames are two-dimensional labeled data structure, consists of rows and columns, just like a table. And please remember, axis equal to zero. Whenever I use a parameter axis equal to zero, it means row. If I'm saying axis equals to one, it means column. So please remember these two things, which will be useful in your next things. So now let me try to create data frame on top of this. The way to create data frame is, remember it's case sensitive, DA, TA, F or AM. The capital is F is capital and D is capital. So what we are trying to do is create a table on top of this. So let's say we are just taking attendance and we would like to create two columns, student names and attendance, yes or no. So let us create a column using our dictionaries like this. Names is my column name for the table, and the students are this array of students. So array, let's say student 1, student 2, and student 3. So please try to understand this. This entire array, this entire list are nothing but student names. This is nothing but, in terms of Python, it's a value in a dictionary. And this is a key in the dictionary. Altogether, it is called as an item. It's a key value pair. So names becomes in data frame as a heading of the table, heading of the column, and this becomes the values of the rows. Let us see how does this look like right now. You see that visualization happening. This is exactly what Pandas libraries is taking care of you in your case. If you just give an input in terms of key value pairs, it generates a table like this with nice visualizations. If you click on some magic, you will also find, if you have, let's say, thousands of records, you can even decide how much to display. All right. So now we will run this again. I would like to create one more column to this. So in that way, I can just give, let's say, scores of the students. Another column. And then how many rows should be there? As I already gave 3 rows, this should also have 3 rows. Let's say 3, 4, 5. And run this. It will create another column called scores, because that is your second key and all the values simultaneously with other rows. So this is how we can create a data frame. This is nothing but a data frame, which I said it's nothing but a table in our real time. But if you want to do some analysis on top of, tables like this, data analysis, this is the way you can do. So let us move on and see what are all the capabilities of Pandas data frames. If I want to display the columns of this table, this specific table, you can have columns. So I did not name it, that's why. So let us give a name for this data frame. Let's say df is my name and run this. Now I saved my data frame. Let me run columns on top of it. So it will tell me that these are the existing columns in my table. All right. So this is how you get tables. Let me give you an example of multiple tables, multiple rows and multiple columns. If you see this example, this is trying to create a data frame, and this is my name. This is a column name for student 1, and then his score is 11. And then the same column, student 2, score is 12. The same column, student 3, the score is 13. So what is the difference? Is there is no difference. You can see this. Let me run this and also show you. See, in this case, we used a dictionary as key value pairs. In this case, I'm using list of dictionaries. If you love writing in this format, please stick to it if you had understood it already. I'm just showing you an alternative way of writing this. If you feel this is a little complex for you, you can just forget it, but this is not complex in terms of understanding. Me repeating multiple times this names, I just reduce it to one time. So this is just an alternative way of doing my table. Similarly, you can also create a table with series. So for example, if I have series like this, so what am I having? In this case, let me also write data 1 and data 2. So please try to understand these two snippets carefully. What I'm trying to do here is data 1, which is a variable having an array which is generated randomly from 1 to 10 range of 5 elements. Simultaneously data 2, which randomly generates 1 to 10 range of 5 elements. If you want to confirm it, just execute for data 1. Understand something is generated like this, and data 2, something is generated like this. So right now we have two arrays generated, data 1 and data 2. I gave data 1 as an input to one series function, data 2 as another series. Now we literally created two different series with some proper indexing. It's completely optional if you want to write it. If you don't want to write it, just leave it empty. It will become 0, 1, 2, 3. So now I just created two series. Let's confirm that again. This was array data structure. This is a series data structure. So now I need to use these two series as values of a table. So let me tell you what I mean to say here. I created series 1 and series 2, which consists of, let's say, 1 to 10 values and 1 to 10 values. I want to give these two series as an input to a table to construct like this. So imagine there are 10 rows and 10 rows. You just need to give a name for this table, just like A and B. So all of this is nothing but a series. All of this is nothing but a series in this case. So let's try to give a name to the column here. So what I'll do is a data frame creation. Data is equals to pd dot data frame. Now I already have series created. I just need to give names to the columns. So what I'll do here is take a dictionary object and give a name for the column. Key is nothing but a column name. Let's say shop 1, which has data 1 as values. So I'll just write data 1, comma, second column shop 2, which has data 2 as inputs. So I'll just write data 2. And this dictionary is given as an input to the data frame, which is a method in a pandas. So when I'm running for data, this is how it looks like. So if you see, this indexing was given in the series itself here, and shop 1 is my column name, shop 2 is another column name. All these data 1 inputs are arranged and organized like this. This is how we create a table using data frames in pandas concepts. I hope you understood this. If you want to see the shapes and all, there are methods for it again. Just go for shape. It will tell you there are 5 rows and 2 columns. Let me run this and keep it as an example for you. So data dot shape gives you the shape of it, which is 5 rows and 2 columns. If you say data dot columns, it will give you a list of column names that you have in this table, which is nothing but shop 1 and shop 2. So now slicing concept is also used here. If you only want to access first 2 rows, you just need to write data is the data frame name, right? Yeah. So data of how many rows, how many columns. In my case, let's say I am expecting let's say only 3 rows, comma, all the columns. Let's cross check the syntax and then the syntax. When I'm actually accessing like this, it will even give you guys which column you want to access. Let us say I am accessing shop 1. It will give you the series values of shop 1. Let me also show you the slicing. If I'm expecting shop 2, This is my shop too. What if I only want to access the first three records? In this case, you can just do, let's say, column column 3. So the first three rows will be visible. This is how you can apply slicing on top of a data frame. So here also, if you say last three columns, you can complete. So these are the two columns, last from the last. So this is how you can access sub part of the tables. So slicing is always remaining same. It's just syntactically also it is remaining same. So I don't think you need to worry about it. So let me take a URL as an example for you. Please try to access this URL that I'm keeping in your Google chat, or you can refresh my page. You will get this. I'm trying to share you guys a URL which consists of a table. So please try to access that URL. It will immediately download a CSV file for you. And I want to see what is there in that CSV file. A CSV is nothing but an Excel sheet, right? So using Pandas, you can just do pd dot data frame. In this case, not data frame. In this case, I want to read the CSV. So read CSV is a method, and I will just paste the URL that we have and run this. This URL I pasted in your Google chat, guys. Please try to access it. Please use the method read CSV, which is from Pandas itself. When you apply this method with this URL in invited commas, please give it as a string. Invited commas, it will try to access this entire data set in your Google Colab itself. This is the advantage of using Google Colab and also the Pandas. So now, for your example, uh, I want to see all the statistics and all the data, a summary related to this data set. You do see that there are 17,000 rows and 9 columns on top of this, right? So now let us say I would like to only access first 100 rows of this data. Just write, is there any variable that I stored here? Not yet. So let me give table1 as my variable name. So all this output will be stored under table1. So now let me use table1 dot head. It means first top. If I mention a number here, top 100 rows. If I say 10, top 10 rows. If I say nothing, it is top 5 rows by default. You can check this. Let me run this first, and then it will understand what does the table1 means. You do see that it is the first 5 rows from 0 to 4. If you are expecting 10 rows, give 10. It will give you access to first 10 rows. Simultaneously, you have tail also. You can use tail. It will give you tail. All right. So if you want some statistics on top of table, please go for describe method. It will give you all the mathematical statistics related to this entire table. So this is how you can play with Pandas library with respect to mathematical or with respect to the analysis. I think there are much more things that you can do with data analysis, but restricting for our electricals part, this is how you can apply this. Again, what if I want to access only latitude values? It means only this column. So table1 is my name, and I am expecting output columns of only latitude. Just use the syntax latitude must be a string input to this function, not function, it is just a representation. You will get all the values related to that column. You do see that this is nothing but a series, guys. This is exactly why we learned series. One column is nothing but there it is generated as an output of series. So this is how you can access individual outputs of columns. Okay. So again, if you want to do slicing on top of it, it remains same. And if you want to do any mathematical operations on top of it, it remains same. Just go and apply df dot mean. It will then be not df, in my case table one. So in this case, these are all my columns that are there in my table. If you see here, if you want to list the column names, you can try table one dot columns. It will give you a list of columns available in that table. When I applied mean function on top of this entire table, it is telling me that for this column, this is the mean. For this column, this is the mean. For this column, this is, and so on. See, you can do this thing with Excel sheet, but you do understand how much time and how much level of understanding and how much level of logic you need to write in terms of Excel sheets or other Google sheets. But when it comes to Pandas library, you can just apply a simple function like this. It will take care of listing everything for you in this much clarity.